Hi guys, welcome to the next lecture. So today I'm going to talk about types of functions according to the elements. What kind of functions can we have? We can have something called one-to-one functions. We can have something called on-to functions. We can have many-to-one functions. We can have into functions. Let's get into the detail what exactly each of them means. I'm going to start with one-to-one function. When can we call that a function is 1 to 1? Suppose we have two sets, set A and set B, and we define a relation between the two sets, which is a function, say f. So here f is A to B. Now f is a valid function from A to B. That means every element in the domain set A should have a unique image in B. So say you have these 5 entries in A, and what we are saying, they need to have a unique mapping. So this is a unique image, this is a unique image, this is a unique image. Now if I just have 3 elements here, then say everything else is mapping to just this third element. Okay. Now, when this is happening, it's a valid function. We don't have any issue. We can even have free floating elements here. It is still a valid function. The restriction is that for every element in A, we need to have a unique image in B. That's the definition of a function. What is the definition of a one-to-one function? As the name suggests, 1 to 1. One element is mapped to one unique element. So hence, for a one-to-one function, one element in A is mapped to a unique element, unique and a distinct element in B. 1 to 1. You are essentially finding out here that the scenario, which was this kind of a scenario that, everything is mapping to say one element, this is not possible. So now I'm going to write it down mathematically. Essentially, we are trying to say here that distinct entries in the domain are mapping to distinct entries in the codomain. Distinct entries means that x1 and x2, they are different. When x1 and x2 are distinct, they are producing distinct images. No two entries can have the same image, which was happening here. So this is not possible. That's what a one-to-one function is. So x1 not equal to x2 should imply f of x1, that is image of x1, not equal to image of x2. In other words, we can also see it from the point of view that if you take one entry in the codomain, that one entry should not have two pre-images. So that means in case fx1 is equal to fx2, that means that the pre-image also will be the same. X1 will be equal to x2, because if that's not happening, that would again give you a scenario where two pre-images are giving you the same value, and that's something that we do not want, right? So one-to-one means that you have a unique pre-image. Having a unique image comes by the definition of a function. Having a unique pre-image is a quality or a characteristic which is associated to a one-to-one function or a one-to-one mapping. A one-to-one function is also called an injective function. Suppose we have a function fx equals to x squared. We have seen this function before as well, right? But now we will think in terms of one-to-one. The graph of this function, it's a parabola. So the graph of the function will look something of this sort, right? Here you have 0, x equal to 0. This is x-axis and this is y-axis, okay? This is x-axis where y is equal to 0. And this is y-axis where x is equal to 0. Now, if you notice in this graph, or if you notice from the function, If you take the input x1 not equal to x2 as say 1 is not equal to -1, right? 1 is not equal to -1. Can you tell me what will be f1 and what will be f of -1? Well, the function is x squared, so when my input is -1, I shall be getting 1. And when my input is 1, then also I am getting 1. I will be getting the same value for 2 points, 1 and -1. If you think in terms of mapping, what is happening? -1 and 1, both are getting mapped to 1. This means this is not a one-to-one function. This is not a one-to-one mapping or function. Now let me take the same example with a bit of a twist. Let's take fx as x squared and let me say that, okay, f is a function which is going from r plus to r plus. What is the meaning of r plus? R plus means 0 to infinity. So that means the domain is 0 to infinity, or in other words, we are allowed to take entries as input from 0 to infinity only. Then do you think we will be able to take the input as -1? We will not be able to do that, right? So I will have to take x from 0 to infinity. And if I do that, I will have to take, say, let's take 1 is not equal to 2. And what about f of 1 and f of 2? Clearly, f of 1 is 1 and f of 2 is 4. So f of 1 is also not equal to f of 2, which means that this indeed is now a one-to-one function, because here if you will think in terms of the mapping, distinct entries in the domain will fetch you distinct entries in the codomain. Now if you want to see the graph, this was the graph, and this time we are only interested in the part which is where x is greater than 0, which means this is the part we are interested in. Your distinct entries will give you distinct images. Or in other words, you have a unique pre-image whatsoever. So therefore, this becomes a one-to-one function. Previously, why was it not a one-to-one function? Here we were assuming that f was from R to R. I could take any real number as an input. I was seeing the whole parabola. But the next question, I gave you a restriction that only see the positive side of x-axis. Then what do you get? Then you get a one-to-one mapping. This was about one-to-one mapping. Now let's talk about onto mapping. Again, from the point of view of elements. What is an onto function? Onto function is a sort of restriction on your codomain. When we are looking at an onto function, suppose this is set A, this is set B, and we define a relation from A to B as F. When would F be onto? Suppose you have entries, 4 entries here. Suppose you have 2 entries here. In case everything maps to both the entries as a valid function. Suppose 2 inputs are going to A and 2 inputs are going to B. Then it's an onto mapping. If suppose everything maps only to A and nothing maps to B, B is an idle element, idle as in which has no pre-image, then it will not be an onto function. So, having said that, what have we realized here? An onto function is a function where you cannot have any idle elements in the codomain. No idle elements in the codomain. That means any entry that is there in the codomain needs to be an image of some entry in the domain, which would essentially means that codomain should be equal to the set of all images, which is called a range. Then only this is possible. Then only you cannot have any idle element in the codomain. So in terms of elements, if this is A, this is B. For every entry in B, you need to have a pre-image in A. Whether it is unique pre-image or it might not be a unique pre-image. As you can see here, these three entries are mapped all to A. That's okay. We're not looking at one-to-one. We're looking at onto. So onto means for every, say, Y belonging to B, there exists at least one. This symbol stands for there exists at least one X belonging to A such that f of x is equal to y. That means every element in the codomain has at least one pre-image. That's what onto means. So it's a restriction on the codomain that you cannot have any free floating elements in the codomain which have no pre-images. Every entry needs to have a pre-image. That means codomain is equal to the range. An onto function is also known as surjective function. An onto function is also known as a surjective function. Let me give you an example of an onto function. So suppose A is the set 1, 2, 3 and B is the set 1, 4, 9. And suppose fx is x square. Okay. Fx is x square and f is a function from A to B. The question is this an onto function? When you would actually create the mapping to visualize whether it is onto or not, you would see that your entries 1, 2, 3, they are getting mapped to 1, 4, 9, that is unique output, and you have no free floating elements in the codomain. In the domain, you can any which ways not have any free floating elements. You cannot have, that's by the definition of a function. In the codomain, this time, you don't have anything free floating. That means it's an onto function. Now for the same function x square, if I tweak this situation, that is, I take f from R to R. The function is x square. This mapping will look like something of this sort. You have entries here, 1, 2, 3. Many entries, the entire R out here, the entire R. What is the range of this function, R square? We've done this. The range of this function, x square, is a positive value. So you will always, what comes out of this function gets generated is a positive number. So the range is R plus. What is the codomain? Codomain is R. This is a situation where these two are not equal. So hence this function is not onto this time. What was happening previously? I had given you limited input 1, 2, 3 and I had given you limited entries in the codomain 1, 4, 9. X square was a onto function. So whether a function is onto or not, it really depends on what kind of codomain is provided to you. So just be very careful. Always remember in basic maths, when we are dealing with the sets and functions specifically, please assume that the function is a real function if nothing has been provided to you in the question. So you will assume that f is from R to R. You will not make any other assumption. But yes, if it is so clearly mentioned that you have to take A as a particular set, B as a particular set, then that's what you will have to handle in the question. Okay. So clearly, this example, in fact, it's not just an onto function. Can you see what is happening? 1, 2, 1, 1, 2, 1, 1, 2, 1. So this is a 1, 1 and onto function. It's a 1, 1 and onto function. This is something I'll take up in the next video. Third thing that I want to talk about are the many to one functions. So the previous example, x square getting mapped. So minus 1, 1, minus 2, 2, minus 1, 1. They're getting mapped to just 1. Minus 2, 2. They're getting mapped to 4. And so on and so forth. So what's happening here? 2 entries are going to 1 entry. This is called a many to one function. Clearly, as the name suggests, many inputs getting mapped to one output. That's what is a many-to-one function. So clearly, many-to-one function is a function where, in case you have two inputs, x1 and x2, they are getting mapped to just a single output, y equals to, which is equal to f of x1 also, and it's also equal to f of x2. You can still have idle elements in the code. Now, then there comes another terminology, which is into function. When is it that we call a function into function? F is from A into B. Now, this essentially means the function is not onto. When is a function onto? A function is onto when the codomain is same as the range, we call the function onto. So clearly the into function is where there exists at least one idle element in the codomain. So that idle element in the codomain means that an element for which there is no pre-image. So some element, at least one element for which there is no pre-image available in the domain, which would mean that clearly this is a case when range is a proper subset of codomain. So when you have to prove that a function is into, you actually just have to prove that the function is not onto. I'll just give you the gist of what we have learned till now. Functions could be, in terms of elements, broadly divided into two parts, one-to-one in terms of mapping, many-to-one. One-to-one mappings look something of this sort. Two distinct inputs give you two distinct outputs. You can still have idle elements in the codomain. That is possible. Many-to-one, in the similar manner, just saw it when two distinct inputs have the same output. Then that's a many-to-one function. You can still have idle elements in the codomain, right? Now let's broadly divide one-to-one. Now the functions could be one-to-one and along with it, they could be onto. The functions could be one-to-one and along with it, they could be into. What is an onto function? Onto function means that range is equal to the codomain. That is, you cannot have any idle element in the codomain. Every element in the codomain needs to have at least one pre-image. You can have more than one. But when we are saying it's a one-to-one function, then every entry in the codomain has exactly one pre-image. Right? So when it is coming down from here, then that means 1, 1 and on. That would imply for every y belonging to B, there is a unique x belonging to A. So for every y, you have a unique x. That would give you a one-to-one correspondence in terms of mapping. So you have a scenario where you have no idle element in the domain and no idle element in the codomain as well. This is a very, very important property, and we'll talk about it in the next video. A one-on-one function, a one-to-one function can also be into. Into would mean that you have some idle elements, extra entries in the codomain. So your range is a proper subset of the codomain, which means that the function is now, if I'm taking the total here, we are talking about the function being 1, 1 and into. Into what would simply mean that it's a 1, 1 function and it's not onto. This kind of a scenario will not happen, that you have a one-to-one correspondence. So in the same manner, for many-to-one function also, you can have a scenario where the function is onto and the function is into. Onto means that your range is equal to codomain, but it's a many-to-one function, so you will not have one-to-one correspondence. No one-to-one correspondence. And on the other hand, in case it's a It's an into function. That just means that the scenario is that it's a many to one case. And you also have idle elements in the codomain. That's it. So that's how we can actually uh, describe the type of functions. Another thing, what you should remember, one-to-one functions are called injective functions and on-to functions are called surjective functions. More on one-to-one and on-to functions in the next video. Thank you.